Hello, this is Martin Mallinson, Silicon Intervention. I've just got through adding the Global Foundries 55 nanometer LP process to the schematic tool that we use, and I'm quite proud of it. And I want to show you quickly how it works. When a process which supports some global controls is selected, these are all the processes we support. This is the new one, 55 nanometer here. There is now the ability to select different configurations here. Post or pre is one of the model settings. We'll keep it on post. The performance can be changed. These are all defined by Global Foundries. You can use RF models or not. You can use Monte Carlo or not. Why don't we use Monte Carlo for just a minute? Monte Carlo with process and mismatch. So it includes a global process and a mismatch. When we switch to this process, the device sizes adjust to some reasonable defaults. Let me just show you that again. If I go somewhere else, the sizes of devices are that. When I go back to that Global Foundries 55 nanometer process, the sizes come out reasonable. This is currently connected to Smart Spice. Smart Spice is hooked up in the background, and so for the Global Foundries process, let me just show you the Netlist Extraction. The Netlist Extraction is quite straightforward. It figures out the libraries that are required. If I turn Monte Carlo off, for instance, here, off, Monte Carlo off, it will now select the non-Monte Carlo models, which are these. If there's a difference between the settings for the thick oxide and thin oxide, it will do the right thing and select the libraries as specified by global. Okay, let's go back to the typical corner and run with Monte Carlo, process, and mismatch, and we'll just tell it to go. So in the outline here, I've defined save everything, connect the output back to the input, just so we can bias it up. That's commented out, and tell Smart Spice to run 500 times. Here we go. It loads up the correct models, runs in the background, one or two little notes about warnings, but we'll let it run. When there's too much printed, I stop, as you can see. I'm just going to make there'll be one window here, makes it a little bit easier to see. One window here, plot the output. Because we've done a Monte Carlo analysis, the tool knows that we probably want to see this. These are the results and the standard deviation, etc., superimposed upon it. That had an offset voltage of mean value 587 millivolts with the standard deviations that you can see. One of the nice features that I've added is the ability to change the threshold. These devices on Global Foundries can have their thresholds decreased or increased. And notice I've bound that gesture to the up and down arrows. So just to show you simply what it can do, I can tell that guy to decrease his threshold. There's now a decreased threshold on that. And I can tell that guy to increase his threshold. There's now an increased threshold on that. The arrows indicate that current will be added, so to speak, to that one, subtracted, so to speak, from that one. If I hold on to these results, I will just hit hold on that and hold on this guy here too. Hold on the, oh, sorry, it's come up on the other window, but hold on this one as well. And press play again, run again now. We expect the threshold to have moved since one of those devices has been selected as having a low threshold, the other one a high threshold. And if we plot the output again, now plot, it will superimpose on this one if we're successful. There we go. And so that was the held one. You can see it's underlined. This is the new one. color it differently. The threshold has indeed moved down. I can bump that threshold down one more step and bump that threshold up one more step, for example, and run again and add the distribution of this one. So you can see that basically the correct processes are being chosen. The support for the different devices is extremely straightforward. You just move over the device and tell it what you want. And I'm going to tell this to add to the current plot. And there that one is, and view max on that. And there are the different things. Change that to yet another color, perhaps. There we go. And we can see that the threshold changes and so forth are all working. So this is the beginnings now of our ability to very rapidly design some hopefully very cool analog circuits in the 55 nanometer process with access to all of the various flags and controls that Global offers in a very simple, just click on it up here and it does the right thing. All right. Hope you found that helpful.